Our next question is find the inverse of matrix A. So for the finding the inverse of any matrix, we know that A inverse, A inverse, which is equal to adjoint of A divided by the determinant of A, right? So just at the first, we have taken here the determinant of A, and by expanding the determinant of A, we have 1. So 1 is not equal to 0. So as 1 is not equal to 0, so this is a non-singular matrix. And at the previous lecture, we have already learned that if determinant A is not equal to 0, so that determinant is non-singular determinant, and inverse of matrix is just exists for a non-singular determinant, right? And if determinant of A is equal to 0, so our A inverse, will be undefined. Okay. So here, if this denominator become the 0, so then the value of A inverse is undefined here. Okay. So here we have just not equal to 0, 1 value. So uh, inverse is exist for this determinant. So now let the Cij, the cofactor of Aij, the all the element in our matrix A. Okay, so the our first cofactor, just taking the at the first the prescribed sign -1 to the power first row plus first column and the minor of our first element. So just deleting the first row and first column, we have this determinant here. Okay, so whose value is 7, and our C12, the second cofactor, -1 to the power first row plus second column with the minor of our second element. So our second element here, the 3. So just deleting the first row and the third column, we have the element 1 3 and 1 4. So with this element we have this determinant, this minor, and whose value is -1. Okay, and in this same procedure we can find out the all the cofactor. Okay, and our adjoint matrix, just put the all the cofactor here. Okay, our first cofactor here 7, and then -1 and -1. So 7 -1 and -1, this first row. And for the second row we have here -3, -3, 1 and 0. Okay, so -3, 1 and 0, and for third row -3, 0 and 1 element here. Okay, and transpose of our cofactors. Okay, transpose our cofactor determinant, so which is just uh, just transform the first column into the first row. Okay, second column into the second row, and third column into the third row, and hence the inverse equal to adjoint of A divided by determinant of A. So our determinant value is just 1. Put here 1 and multiply with the adjoint of A. So adjoint value is this. This is our adjoint value. So just put here, and our final answer will be this matrix. Okay, so this is our final answer.